Alright guys, welcome to the Algebra 2K square roots and inverses review. So for number 1 and 2 it says graph the following transformations of the square root function, identify the transformations and give the domain and range of each graph. Alright, so one thing y'all need to be able to identify is that this isn't in graphing form yet, or in the correct form. Here inside the square root we have negative 1/2 x plus 2. So here you could rewrite this as 3 square root. So if I factor out the negative 1/2, alright, if I factor out negative 1/2 from 2, we get negative 4. And then we have the minus 1 at the end. So the vertex should be at 4, 1. Right, you could also go to y equals. Type in the original one into, type it into y1. Also, if the number's outside the square root, make sure here you're outside the square root. So here the minus 1 is on the outside, so I'm going to graph it. As you can see, we have a bunch of errors right here. The errors stops at 4, negative 1. So that's where the vertex should be. Let me fix that. It should be at 4, negative 1. So right here. And then let me just get some other points to make the graph. So we have 2, 2. Alright, so just pick the easiest points you can fit on this graph. So 2, 2, we got negative 4, 5. Alright, then after that, negative 14, 8, which doesn't fit on the graph. So just follow your 3 points and then draw in the square root function. Alright, so this is going to be our graph. Now let's get the transformations. So this 3 right here is telling us vertical expansion by 3. The negative on the inside is telling us horizontal reflection, or reflection over the y-axis. Alright, so that's the reason why the function is pointed this way instead of going this way. So it reflected over the y-axis, so it's now pointed towards this direction. Alright, and then the 1/2 is a horizontal, so it's 1/2, so expansion by 2. Let's remember, everything inside is the opposite. So if this was on the outside, you would say vertical compression, but since it's inside the square root, you say horizontal expansion by the reciprocal, which is 2, and then it's also going to shift right 4, down 1. Right, then for domain and range, again it's pointed this way, so for domain it starts at negative infinity and then stops at 4. And then for the range, which is from bottom up, we start at negative 1 and then keep going up. So negative 1 to infinity. Alright, so now let's move on to number 2. So same thing happens here. This 2x plus 6, you could factor out the 2. Alright, so negative 4 square root. If I factor out the 2, we're left with x plus 3 on the inside, plus 5 on the outside. So this would have a vertex of negative 3, 5. And again, if you type the function to y equals, you could see that the vertex is at -3. Got -3, +5. So -4 square root 2x plus 6 plus 5. Alright, so again, here you see a bunch of errors. Wherever the error stops, that's the starting point. So -3, 5. Then -1, -3. Alright, so we have -3, 5, -1, -3. And then 5, -11, which kind of comes off the graph. And then just so you can tell how the graph is going to look, just graph it. You can tell right there it's going to go this way, so follow that exact same pattern. Alright, so just go like this. Right, then for the transformations, we have this negative in the front. That's a reflection over the x-axis, so that's why it's upside down. Right, we have the 4 right there, which is a vertical expansion by 4. Now we move inside the square root. This 2 would be a horizontal compression by 1/2. And then it goes left 3, up 5. Alright, so again, be careful with this part. It's not left 6, because you have to factor out the 2. Same thing on this last one. It's not left 2. You have to factor out the -1/2. Alright, so be careful on these. Alright, and then domain and range. Alright, for domain, left to right, we start at -3. And then continue going towards positive infinity. And then for the range, since this is upside down, we start at -infinity and then stop at 5. And also remember, your vertex helps you with the domain and range. Right, remember the vertex was -3, 5. These numbers are usually involved with the domain and range. So this -3 isn't involved, it's involved with the domain. This range of 5, or the y value of 5 is part of the range. Same thing on this last one. Here the vertex was 4, -1. The x was 4, it was part of the domain. The range, or the y was -1, it was part of the range. Alright, so now let's look at 3, 4, and 5. So use the square root parent function, write an equation for the following described functions. Alright, so they gave us the transformations, we have to come up with the equation, and it's a square root. So y equals, we have parent function that is compressed vertically by a factor of 1/3, so this is vertical, so it goes on the outside, and then translated 3 to the left. So if you want the graph to shift left 3, we need +3 inside the square root. Right, for number 4, reflection over the y-axis, so we need a negative inside the square root. It's stretched horizontally by a factor of 6, and then translated right 2. Right, so reflection over the y-axis, so the negative is on the inside. This is a horizontal stretch. So horizontal also means the inside. So remember, this is completely the opposite. So instead of 6, you would put 1/6. Alright, so if you had the 1/6 on the outside, you would say vertical compression. But this being on the inside, it's the complete opposite. So we would say horizontal expansion or stretch by 6, which is the reciprocal. And then to go right 2, parentheses, x minus 2. Alright, so this is the correct format. Let me just write it up here so we can remember. So the format is y equals a square root b parentheses x minus h plus k. Alright, so then for number 5, this time we have the vertex given to us, so we have h and k. And the function is reflected over the x-axis. Alright, so we need a negative at the very front, square root. Alright, our vertex is 3, negative 9. So since the vertex is at 3, we know we went right 3, so this would be x minus 3 on the inside. K is negative 9, so this shifted down 9, so minus 9 on the outside. Alright, so the vertex is at 3, comma, negative 9. Alright, so let's move on to the next page. Alright, so this next page is on inverses. So we need to find the inverse of each of the following functions algebraically, show all your work. Graph each function in its inverse, label or color code, state domain and range of both the function and the inverse, circle yes or no if the inverse is a function. Alright, so let's graph this one first. So this is just a linear function. Y-intercept is negative 3, slope is 7. So 1, 2, 3, 4, 5, 6, 7, right 1. 1, 2, 3, 4, 5, 6, 7, right 1. So this one comes off the graph. 2, 3, 4, 5, 6, 7, right there. Alright, so use this. Alright, so that's the original one. So now let's find the inverse. Alright, so to find the inverse algebraically, you have to switch x and y. And then solve for y. So here, add 3. And then divide by 7. Alright, so the inverse equation is x plus 3 over 7. Alright, so we could graph that one also. I'll type it this way, x plus 3 so that's also a straight line, second table. Alright, so we got a point at 4, 1. See, point at negative 3, 0. Negative 10, negative 1. Alright, so this is going up 1, right 7, up 1, right 7, up 1, 1, 2, 3, 4, 5, 6, 7. Oh, shoot. Alright, so for the original one, alright, these are all straight lines, so domain and range is always all real numbers. Same for the inverse. And then, is the inverse a function? So you could either go on the calculator, just check the points, and see if they just have the x and y switch for the inverse. So for example, here we have 1, 4 for the original one. So if I take the inverse of that, we should have a point at 4, 1, which we do. Alright, we have another point at 0, negative 3, so there should be a point at negative 3, 0, which there is. Then remember, all inverses reflect over the line y equals x. So this line right here. And then here it looks like it does. Alright, so yes, this would be an inverse. And you could also check it using composition. So if you were going to use composition, you would plug this into there. So the inverse into f of x. So you would have 7 parentheses x plus 3 over 7 minus 3. The 7s would cancel. You get x plus 3 minus 3. Then you just have x. Right? Then you could check it the other way. You could plug this in for that x. So we get 7x minus 3 plus 3 over 7. Your 3's would cancel at first. You get 7x over 7. And then you get x. So that's another way you could check. That's composition. Alright, then for number 7, this time we have a quadratic, so this is going to make a parabola. So the vertex would be at 4, 0. Right, then I could just follow the pattern, write 1 up 1, write 2 up 4, write 3 up 9. Alright, so that makes a parabola. So now let's find its inverse. Alright, so let's switch the x and y. Alright, so let's square root both sides. We get the square root of x equals y minus 4. Then add 4 to both sides. So our inverse here is square root of x plus or minus plus 4. Let me write that a little bit better. So f of negative 1x plus or minus square root of x plus 4. Alright, so now we got to graph this one. Again, all you could do is just take these points and just flip their x and y's. So here we have 1, 9. If I flip that, we get 9, 1. Here we have 2, 4. If I flip that, we get 4, 2. We got 3, 1. If I flip that, we get 1, 3. We got 4, 0. If I flip that, that's 0, 4. We got 5, 1. Flip that, that's 1, 5. 6, 4. Flip that, that's 4, 6. 7, 9. If I flip that, that's 9, 7. Alright, so that's the inverse. Alright, the original one has a domain of negative infinity to infinity. The range would be from 0 to infinity. And then remember, for the inverse, all that happens is that the domain and range switches. So here, domain would be from 0 to infinity. The range would be from negative infinity to infinity. Alright, then we can see that 0 to infinity, negative infinity to infinity for the range. And then is this an inverse? Yes, because all we did was just switch the points. Alright, so now let's look at number 8. Alright, so for number 8, we have a square root function for the original one. So the vertex here, the starting point, would be at negative 2, negative 7. Right, you could plug that into the calculator to get the points, or you could just follow the pattern. There's no expansion or compression, so I could just go write 1 up 1, write 4 up 2, write 9 up 3. Alright, then if you just want to see where I'm getting those points, you just plug it into the calculator. Alright, so starting point is at -2, -7, so that's on here. We have -1, -6, which is also on here. Then we should have a point at 2, 5, or 2, -5, that's right there. Another one at 7, -4. Yeah, right there, 7, -4. Alright, so domain and range to this one. Domain would be from -3 to infinity. Range would be from -7, sorry, not -3, -2. So -2 to infinity, and then for the range, -7 to infinity. Alright, so now let's find the inverse. Alright, so just heads up, this isn't a full parabola, so just heads up for when we find the inverse. So I'm going to start off by switching the x and y. Alright, add 7. Square both sides. Here guys, also heads up, when you're finding the inverse, do not FOIL this. Just leave it the way it is, x plus 7 squared. Because you're trying to put it in graphing form. So x plus 7 squared equals y plus 2. Then just subtract the 2. So when finding the inverse, do not FOIL this. You're trying to keep it in graphing form. So your inverse should be x plus 7 squared minus 2. Alright, so if I graph this, we have, right, the vertex would be at -7 to -2. Here is also, the reason you have to be careful on these is because when you find the inverse, this is a quadratic. So when you graph it, you would get a full parabola. Okay, so let me graph the full parabola just real quick so we can see it. So -7, -2. Alright, so this would have a domain of -infinity to infinity, but remember, for the inverse, these switch. So the domain should be from -7 to infinity, and then range would be from -2 to infinity. So the domain restriction should be at -7 to infinity. You can also get that from the k value of the original square root function. So this was -7, so when I find the inverse, I know that's going to be -7 to infinity. So the range of the original one is the domain restriction of the inverse. So when I restrict this to -7 to infinity, all we're going to do is worry about this side right here. Like this left side, just ignore it. Right, so the inverse is just this right side from -7 to infinity. And then for the last question, is this an inverse? Yes, again, you can just check on the calculator to see if the x and y switch. Alright, so for example, here the vertex is at -7, -2. The original one had the vertex at -2, -7. So that's flipped. Here we had a point at -6, -1. This has a point at -1, -6. So it's just all the x and y's just swap. So yes. Alright, so now for numbers 9 and 10, it says use composition of functions to determine whether the functions are inverses. Alright, so first let's do f of g of x. Alright, so the input is g and the function is f. So we're going to take g and put it in for x for function f. So the way this is going to be written is 5 over, so the x is going to be x minus 1 over 5. plus 1. Alright, so let's try to fix the bottom. So right now, if we're going to add these two fractions, they both need the same denominator. So let's treat the 1 like 5 over 5. Alright, so now we could add this. So x minus 1 plus 5 would be x plus 4 over 5. Alright, so this was just adding two fractions. You need the same denominator, so we made this 5 over 5, so they both have the same denominator, 5. And then 5 over x plus 4 over 5, you would do keep, change, flip. So you would keep the 5, flip this fraction to 5 over x plus 4, and get 25 over x plus 4. So obviously on this one you don't get an x, so you could just stop there and say this is not an inverse. Not inverses. Alright, so you have to get an x, and then if you get an x, you have to do it the other way. So let's look at 10. So let's start off by plugging g into f. Alright, so f of g of x, this would be square root of 3. Inside we got x squared over 3. Here, this 3 and this denominator of 3 cancel out, so we're left with square root of x squared, which gives us x. Alright, so f of g of x works. Since this works, now we have to test it the other way. So now let's test g of f of x. Alright, so now we're going to take this one, plug it into this one. Alright, so if I take this, plug it in for that x, we got square root of 3x for the numerator being squared, and the denominator is 3. This square root, that squared, cancel each other out, so you're left with 3x on top, the 3 on the bottom. Those 3 reduce to a 1, and you're left with 1x. Alright, since both of these scenarios gave you x, yes, these are going to be inverses. Alright, so now for number 11, find the x and y intercepts of the function y equals x squared minus x minus 6, then find the x and y intercepts of the inverse. What do you notice? Alright, so solving this would give you the x-intercept, or factoring it. So let's factor this. The factors that would give us negative 6 and negative 1, that would be x minus 3, x plus 2. If I set them equal to 0, we get x equals 3 and negative 2. So the x-intercepts of the original one would be at 3, 0, and negative 2, 0. Or you could just graph it. I guess that would be an easier way you could do this also. X squared minus x minus 6, go to the table. Right, where y is 0, those would be the x-intercepts, so at 3 and negative 2. Right, so we see that. Right, so these are the x-intercepts of the original. Now let's find the y-intercepts of the original. So y is when x is 0. So go to where x is 0, that's 0, negative 6. Alright, so now for the inverse, alright, for inverses, it's just the x and y being switched. Alright, so if we switch these, we get 0, 3, 0, negative 2. So if these are going to be points on the inverse, they both start with 0. These are going to be the y-intercepts of the inverse. Then if I flip this one, we get negative 6, 0. Since the y is 0, that's going to have to be the x-intercept of the inverse. Alright, so it's just about switching the x and y. Just remember, the x-intercept is when y is 0, the y-intercept is when x is 0. Alright, so now let's look at the solving. So solve each equation, show all work, be sure to check for your solutions, and eliminate any extraneous solutions. Alright, so for number 12, I'm going to go ahead and divide the 2. So we get square root of x plus 1 equals 7. My square root is isolated, so I can square both sides. We get x plus 1 equals 49. Subtract the 1. X equals 48. Alright, then let's just check if this works. So y1, I'm going to put the left side, which is 2, square root of x plus 1. y2, the right side, which is 14. Go to the table. Let's go to 48. They both have 14 and 14, so that works. Right, 13 is kind of like number 12. Start off by dividing this 5. Right, and then square both sides. We get 4x plus 3 equals 9. Then we're down to a two-step equation. Subtract your 3. Divide by 4. And then 6 over 4 is just 3/2. Alright, so let's see if this works. So y equals 5 square root of 4x plus 3. And then y2, 15. Alright, let's go to table set, and then you just put 3/2. See if you get the same y1 and y2. So 15 and 15, that works. Alright, now for number 14. So right now we have 2 square roots on each side. Let's move one of them to the other side. So let's add square root of 2x minus 4. So square root of x plus 6 equals square root of 2x minus 4. So now, since they're on 2 different sides, I can go ahead and square both of them. On the left side, we get x plus 6. On the right side, we just have 2x minus 4. So all that happened was the square roots went away. And then let's get the x's on one side, all the other numbers on the other side. So for this one, I'm going to go ahead and subtract the x, because I know this is just going to give us 1x. And then I'm going to go ahead and move this 4. So add 4 to both sides. That goes away. And then 6 plus 4 is just 10. So x equals 10. Alright, so let me just check if this works. Square root of x plus 6. For y2, we got square root of 2x minus 4. Alright, so again, you could either plug in the original one, like plug all of this in for y1, 0 for y2, or you could plug this one in after we move the square root of 2x minus 4, so it will still give you the same thing. Alright, so let's go to 10. So table set 10. Alright, 4, 4, so that works. Alright, so number 15, square root looks good, so let's just go ahead and square both sides. Alright, this you have to FOIL. So remember, x minus 5 is not x squared plus 25. This is x minus 5 times x minus 5. Alright, so on the left side, we know we just get x plus 15. If I FOIL this, we should get x squared minus 10x plus 25. So this is a trinomial, so if we're going to solve a trinomial for x, we have to set it equal to 0 so we get factor. Alright, so let's move this x, move this 15 to the other side. Alright, we got x squared minus 11x plus 10. And then you got to find two numbers that multiply to 10, add up to negative 11. Alright, so let's see, what multiplies to 10 adds up to negative 11. That would be x minus 10, x minus 1. Negative 10 times negative 1 is 10. Negative 1 sorry, negative 10 plus negative 1 is negative 11. If you multiply them, you get 10. Alright, so now set each one equal to 0. And we should get x equals positive 1 and 10. Alright, but then we got to check if they work. Alright, so square root x plus 15, x minus 5 for y2. And if I graph it, you can see there's only one intersection, so there might only be one solution. So let's just confirm it. So 10 looks like it works because it has 5 and 5 for y1 and y2. Then if I go to 1, it has 4 and negative 4. So 1 would be extraneous. 1 does not work. The only solution here is 10. Alright, so that's why it's important to check your answer, because sometimes one of them doesn't work. Alright, then number 16 is kind of like 15. We have to factor on this one also. So go ahead and square both sides. We get 3x minus 11 equals x squared minus 6x plus 9. So that's what you get when you FOIL. Subtract 3x, add 11. Right, because you want to set it equal to 0. So we got x squared minus 9x plus 20. Then we got to find two numbers that multiply to 20, add up to negative 9. That would be x minus 5, x minus 4. If I set those equal to 0, we should get x equals 4 and positive 5. Alright, so now let's see if those work. So 4 looks good, 5 looks good. Alright, so both of them look good. Alright, so on number 17, we have this 4 right here. It looks like I could divide it to this side. Those 4's go away. We get 7x plus 18 equals 4x over 4 reduces to 1x. Alright, so the square root's on its own now, so let's go ahead and square both sides. So we got 7x plus 18 equals x squared. Alright, so you see this x squared? That should be kind of telling you that you might have to set up a trinomial. So let's move this 7x, let's move the 18 to the other side so it could equal 0. Alright, so we got 0 equals x squared minus 7x plus 18. Then we got to factor this. So what would multiply to 18, add up to negative 7? Alright, so what would multiply to 18, add up to negative 7? That would be negative 9 and 2. So always be careful when you do this part. So x minus 9, x plus 2. Right, negative 9 plus 2 is negative 7. Negative 9 times 2 is positive. Hold on. Let's see, this should be minus 18. That's my bad. So that should be minus 18. Alright, that's why you should always do this stuff in pencils. So let me just rewrite it. X squared minus 7x minus 18. So that's what it should be. So x squared minus 7x minus 18, that's why I'm using negative 9 and positive 2. Negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. So now these are going to be the two factors. Set them equal to 0. We get x equals negative 2 and 9. So now let's see if they both work. Alright, so I'm just going to put what we got after we divided the 4. So we have square root of 7x plus 18 Again, you could just always put the original ones. And then after I divided the 4, we had an x on the right side. Alright, so negative 2 does not work. Let's just look at 9. Alright, 9 works. Alright, so then for number 18. Alright, so this is 9 plus. Alright, so this operation right here is a plus, so we have to subtract this 9 to both sides. Alright, so you're not dividing by 9, you're subtracting 9. So then we get square root of 4x plus 8 equals 2. Then let's go ahead and square both sides. We get 4x plus 8. Guys, and don't forget to square the 2. 2 squared is 4. Then we're down to a two-step equation. Subtract 8. We get 4x equals negative 4. Divide by 4. X equals negative 1. Alright, then let's check if this works. Alright, so again, you could plug in the original one, so I could do that, or plug in the one after you subtracted the 9. So 4x plus 8, and then 11 for y2, go to the table, negative 1 works, so we're good there. Right there. Alright, so now on 19, right, cannot square first, I have to get rid of this 9, so minus 9 both sides, we get square root of 5x plus 1 equals negative 6. Here guys, so on this one, just based off this, I have a square root that equals a negative 6. Just based off this, I know this is going to be no solution. Right, because I can't have a square root that's going to give me back a negative 6. Right, that just can't happen. So, here, so let's just go ahead and finish this. Alright, so I would get 5x plus 1 equals 36. Subtract the 1, you get 35. Divide the 5, you get 7. Alright, you would, if you kept going, you would get a 7. But it should not work just based off what we saw after we subtracted the 9. You had a square root equal to a negative number. So here I'll type in the original one. So square root of 5x plus 1, make sure you're outside the square root for the plus 9, equals 3. Alright, go to the table. Our answer was 7. There we can see it. Y1 is 15, Y2 is 3. That does not work. So that just confirms that this is not a solution. So no solution on this one. So again, if you see a square root that's isolated, there's nothing around it, and it equals a negative number, you can tell that it's going to be no solution. But if you can't tell from the beginning, just go ahead and finish the rest of the problem. Once you check your solution, it should not work, which would happen here. The 7 did not work. Alright, then on 20, let's go ahead and square both sides. We get 7 plus 3x equals 4. And we just got 2 steps. Subtract 7. Divide by 3. We get negative 1. Alright, then here let's just check it. 3 times negative 1 is negative 3. Plus 7 is 4. Square root of 4, you get a 2. So that should work. Alright, there you can see it. Move this. There we can see it. Negative 1 has 2 and 2. Alright, so now let's look at 21. Alright, so 21 is another one. Make sure you know how to do this one. It's a little bit different than the ones we just did up here. Alright, so on this one, if you add the 2, it's not going to make much of a difference. You still have 2 square roots. They're both on different sides of the equal sign, so that's good. So let's just go ahead and square this. Right, but if you square this, we know that the square root just goes away. It's just 11 minus x. But this, you're going to have to FOIL. So let's do that off to the side somewhere. So let me do that. Another piece of paper to do this. Let's do that right here. Alright, so we got negative 2 minus square root of 7 minus x times negative 2 minus square root of 7 minus x. Alright, so let's FOIL this. Negative 2 times negative 2 is positive 4. Negative 2 times negative square root of 7 minus x is positive 2 square root of 7 minus x. Same thing here. Positive 2 square root of 7 minus x. And then negative square root of 7 minus x times negative square root of 7 minus x would give you positive 7 minus x. Alright, so all that happened was the square root goes away and you just have 7 minus x. Combine your like terms, we get 4 plus 4 square root of 7 minus x plus 7 minus x. Right, we got the 4 and 7 we can combine also. So 4 square root of 7 minus x. 4 plus 7 is 11 minus x. Right, so let me write that down here. So 4 square root of 7 minus x plus 11 minus x. Alright, so let's see what else we can combine. So here we have an 11 and 11. I can go ahead and subtract those. So minus 11 to both sides. I can move this x also. So let's add that x to both sides. Alright, so we can see what ends up happening on here is this cancels. This cancels. So on the left side we have a 0. Alright, so we got a 0 there. And then on the right side, you still got 4 square root of 7 minus x. Alright, so let's divide this 4 to both sides. Alright, 0 divided by anything is still going to be 0. Alright, so let's get rid of the square. So square both sides. 0 squared is still 0. 7 minus x. And then let's make this x positive by adding x to both sides. So that goes away. We got 0 plus x, which is x equals 7. Alright, so the main thing about this one was the foiling, which is what we did right here. Right. Move everything to one side that's not involved with square root. So I moved minus 11 there, plus x there, which gave us a 0 there. Divided the 4, squared both sides, and then I was left with 0 equals 7 minus x, and then just solve for x. Alright, but then let's check to make sure that's the correct answer. Square root 11 minus x. Then we got negative 2 minus square root 7 minus x. Alright, then we said it was 7. Oh, so right there, 2. See if it focuses. You can see 2 and negative 2. So this is actually going to be no solution. 7 doesn't actually work. Alright, so again, that's why it's important to check your answer after you complete the problem. Alright, then on 22, you have your 2 square roots on each side, so that's good. So go ahead and square both sides. We get x minus 3 equals x minus 21. If I subtract x to both sides, your x's go to 0. We get negative 3 equals negative 21. That is a false statement, so no solution. Negative 3 does not equal negative 21. Alright, so that's the solving. Again, just make sure to always check for your extraneous solutions. And let's go to the last page. Alright, so this is a Pythagorean theorem question. So remember that's a squared plus b squared equals c squared. C is the hypotenuse. Alright, so I'm going to make this a. So we got x minus 1 squared. Then we got plus L squared equals 3x squared. Alright, so if I square this, that means I have to FOIL it. X minus 1 times x minus 1 is x squared minus 2x plus 1. L squared is just L squared. Right, 3x squared, what's 3x times 3x? That would be 9x squared. Alright, so let's try to keep everything positive. If I move the minus 9x to minus 9x squared to this side, it's going to make it negative 8x squared. So let's move all this to this side just to keep the x squared positive. So that's minus x squared plus 2x minus 1 minus L squared to both sides. Alright, so we got 0 equals 9x squared. Let me just write it this way. 2x minus 1 minus L squared. Combining like terms, we get 8x squared plus 2x minus 1 minus L squared. Alright, since we're solving for L, let me get the L by itself on this side. So let me add L squared. It probably would have been smarter just to keep it over here. Alright, so L squared equals 8x squared plus 2x minus 1. Alright, so then we got to factor this. Alright, so you could split the middle term. Alright, so for this one we're trying to solve for L, so don't factor this, just, sorry, so I should have read the problem. Use the Pythagorean theorem to solve for the length L. So all we're doing is solving for L, so to get L by itself, just square root both sides. So L equals square root 8x squared plus 2x minus 1. Alright, so all you're doing is solving for L. Alright, so the goal was just to get L by itself, so we should have just minus the x squared plus the 2x minus the 1, left the L squared here, and then square root the L squared to get the L by itself. Now B says find the value of L that corresponds to a hypotenuse of 6. Alright, so if the hypotenuse is going to be 6, that means x would have to be 2. Alright, so let's find what the length L would be when x is 2. So we already have an equation for it. 8, 2 squared plus 2 times 2 minus 1. So, alright, 2 squared, that would just be 4 plus 2, that would be 4. 2 times 2 is 4 minus 1. 8 times 4 is 32 plus 4 minus 1. that would be square root of 35. So that's what I'm doing, square root of 35. And then here, let me just, it's kind of a way to check. So if I were to just plug this in exactly how we had it, 8 parentheses 2 squared plus 2 times 2 minus 1, we get that, and we got square root of 35, so let's see if that's the same thing. Yeah, so that works. Alright, so that's the end of the review. Good luck, and yeah.